The Newton's law of cooling problem, and if we take a look at the book on page 275, we're given that formula for Newton's law of cooling. The temperature based on time is dependent on some initial temperature, E raised to some constant times time, plus the temperature of the surrounding environment. So for this one, what we need to do is we're going to have to create an equation first to do any of this. So they're telling me, let's see, the temperature at time 0 is 165. So I know 165 degrees equals some initial value that yet to be determined. And that's at time 0. And that's in a 75 degree room. So what this will let us do is this will let us find that constant in front of the E. So I'm going to subtract 175 from both sides, and if I'm doing my arithmetic right, that's 90. And I know that k times 0 is 0, so e to the 0 is 1, so that's what that's what my initial term is. So what I'm going to do is I'm going to come back up here just so I don't take up quite so much board space. And I know T in the surrounding area is 75. Okay, so far so good. Then we're going to use the fact that in 30 minutes, half an hour, the temperature is cooled to 145. That'll allow us to find that K, that factor, that multiplier. So 145 equals 90 e to the I don't know times 30 plus 75, which is again, let's see. Oh, actually, shouldn't say again. What is that? 70 equals 90 e to the 30k. So I'm going to divide by 90. That gives me 7/9 equals e to the 30k. Now what's nice about this, I'm going to take the natural log of both sides of this equation, because the natural log and the e will cancel. That gives me the natural log of 7 divided by 9 equals 30k. So the constant will be the natural log of 7 over 9 divided by 30. Okay, so that's the constant. So we can write our equation now. T of t equals, is it 90? Yeah. 90 e to the negative 0.008377. I have no idea how many decimal places to use. T plus 75. Okay, so that's our equation. Now we need to, what would the temperature be after 50 minutes? Well, what's T of 50? And we're just going to replace the T with 50. And just evaluate that. So I paused that while I calculated it, and I got 134 degrees, a little better than 134 degrees. And then how long will it take the turkey to cool to 110? Well, that's the Y value, right? So 110 equals 90 e to the negative 0.008377 t plus 75. Now we're just going to solve that equation. Let's see, what is that? 35 equals 90 e to that mess on top. I'm going to divide by 90. Take the natural log of both sides, because that cancels out that e, and that's what we want. Make it easy as possible. Then I'm going to divide that natural log of 35 over 90 by that negative 0.008377 or whatever it is, t. All right. So let's see. I'm going to grab that number. I am going to store that in a variable. And then I'm going to take the natural log of 35 divided by 90. I'm going to divide that by that variable I stored, and I'm getting 112, almost 113 minutes. Okay, and that's a Newton's law cooling problem. You'll see more of this in calculus.